Hey everybody, I am here with Roger, aka Nemesis, who just enabled us to be able to do laser active emulation via the Ares emulator. And I am just really interested to talk to you about how all of this came about and basically hear your story start to finish. So thank you, Roger, for joining us. I really appreciate it.
No worries. Thank you for having me.
So, do you want to give us just like a very quick overview of what it is that you did? Because many of us
Yeah.
already understand it and have followed your work, but for those of you who don't, maybe just like a 10-foot view of what it is that you accomplished.
Yeah. Well, it's funny because in the end, it's been a long journey, and in the end, it sounds quite simple when I just sum it up. But essentially, we had these games that were made for the Pioneer LaserActive. Specifically, right now, the Sega pack for it, which is what's emulated currently, and they're encoded on LaserDisc. And I know you've spoken in the past with Chad Page and Simon, who did the Domesday duplicator, and has talked quite a bit about LaserDiscs in the past. I saw your podcast on that. Um, and the format presents some unique challenges. And so emulating the system was not so much a problem of emulating the hardware. In fact, back in about, I think it was about 2011, I have to go check my notes. I did quite a bit of reverse engineering on the hardware and figured out what a lot of that stuff does. And that information's been out there, sitting there in the public domain, for over a decade now. But the challenge has really always been on the unique nature of this format. And um, the biggest challenges were came back to the video in the end. Emulating the hardware. In fact, let me grab a Sega pack module. So this here is the pack module that goes into the LaserActive, the Sega pack module. It's on two boards and it comes apart like so. This is effectively a Mega Drive plus Mega CD miniaturized in one little unit. And this is what drives the actual playback of the game. So emulating the hardware is basically the laser active itself. The entire unit is pretty much like an expansion module for the Sega. That's kind of how it works. So it's kind of like you have a Mega Drive and a Mega CD, and then we're going to add on this other peripheral, which is the laser active. And so, from an emulation perspective, that's kind of the way it works. You have to start with a working Mega Drive emulator and a working Mega CD emulator, and then you add something a little bit extra to make the laser active work. And so, a lot of the work in emulating the system was not so much reverse engineering the hardware, because it did a lot of that a long time ago. It was really around, okay, we know what the hardware does. How do we capture these games? you know, um, yeah,
So, I guess this is let me just kind of pause for a second and give my understanding of how these work. And essentially, certainly the two games I had hands-on experience with, it seemed like essentially a Genesis overlaying its graphics over 480i composite video quality laserdisc video.
mm,
And the player itself was essentially hardware that interfaced with the Genesis controls, saying where to go on the disc, where to play what part of the video. And there must have been some data in there as well that got loaded into RAM that could
yeah.
control all that. Is that, I know that's a gross oversimplification, but is that like a good way for the novice to visualize how this whole system was working together?
Yeah, essentially, there's a bit more nuance with the video mixing, which we'll talk about. But effectively, the way the Mega CD hardware works, or the Sega C, sorry, you're in the US over there for all our US listeners. The Genesis and Sega CD combo. Um, when they're loading a game from an audio CD or a regular CD, they use a data track that has program code, and they can load off chunks of data into RAM on the Mega CD, and they run code from that. And so the Laser Active is doing exactly the same thing. Like, I mean, literally exactly the same thing. They have a digital audio track, which is actually effectively a CD. It's Red Book standard encoded, and that has a data track on it that has the same kind of program code, and it loads that into the same memory, and it starts running the game. The only real difference is, in addition to the CD tracked information, you've got a whole analog and analog video and audio system there as well, which is also available. And yeah, it mixes the two together, and there's actually a lot of power with that. It's not just simply saying, okay, we have laser active video stream here and we have the Mega Drive graphics here. There's actually full analog faders, so you can pull them up and down by different degrees. You could have, the Mega Drive graphics kind of partially semi-transparent, blending with the video feed. And it's not actually just 480i content either. The LaserActive has a digital memory buffer, and one of the reasons it needs that is most Mega Drive games are not running at 480i; they're running at 240p. And when you have a 480i signal and a 240p signal, you can't just mix the two together. The timings are off, right? So it actually uses that digital memory buffer to composite the graphics. And it can kind of match these mismatched signals in terms of their timing information and blend them together. So but it does enable some very interesting and unique things on the hardware because, traditionally, if you're playing a LaserDisc, it is running at 480i. That's the only option you have. On the LaserActive, that's not true. You can be running at 240p, and you can pick. Am I running at 240p at 60 hertz, or am I running at 240p at 30 hertz? And showing just every odd or every even field, they start splicing multiple video streams into the same space on disk. And pretty much every game uses that. It's how you get branching logic because the video stream is fixed; it's already baked in the disk. That video can't change. But when you have a game that wants to run like a full motion video background, for example, and let's say you're in a space simulator and you're flying through, you might reach a point where they want to give you an option: do you go left or right?
Mhm.
And that's the way they achieve that. They'll basically have, well, one video stream, one field will start diverging and have the video stream where you go left. The other will have it where you go right, and the two are happening on the same place on disk. And so effectively, you've gone, instead of being 240p at 60 hertz, you have lost half your frame rate. You're running 240p at 30 hertz, but you get to stack that video on top of each other. And that's presents some
That's
unique
kind of
challenges
ingenious.
itself. Yeah, it was extremely powerful hardware. And it was very, very expensive hardware for the day. That digital memory buffer, the cost of that kind of memory in that age was not cheap. This is
Hmm.
extremely fast dual ported memory, and like the Mega Drive itself. I don't know how well this is known as this is. The Mega Drive itself has 64 kilobytes of VM memory. They
Mhm.
designed the hardware for double that, 128 kilobytes, and they cut the extra half for cost reasons. But the Sega Terra Drive had the full 128 because they had other ideas for that. That memory, they've got a stack more memory than 64 kilobytes in there for that VIA memory buffer. That's part of the reason why this hardware was so expensive in the day. And unfortunately, the player itself is not very reliable because they really squeeze down the manufacturing to the lowest price point in other areas. You can really feel where they've really dropped the quality, which
Huh.
unfortunately makes the players, even if you can find a player today and buy one, it's probably not going to work too well until you do a bunch of work on it, which is the unfortunate reality of this hardware. One of the reasons it's
Yeah.
important to preserve it. Yeah.
So that was fascinating because I always wondered why it was so expensive, and I always thought this was just like a jack the price up for rich people kind of thing. But you're right about the other aspects of it were relatively low quality considering, the price and other devices of that era. And I didn't realize it actually required the much more powerful hardware, which, I don't want to say justified the cost, but at least explained it in a reasonable manner.
It made it very hard for them to cost cut. And I'm sure that they probably are aware that the price did not help the sales of this unit. And,
Right.
it's one of these just these factors where they probably actually squeezed down the cost as much as they could. One of the most unreliable parts of the hardware is actually these Sega packs, like all these different. Yeah, I've had to recap this because all these capacitors have failed.
Yeah.
That was not on Pioneer. That's bad luck. And around the time they obviously had, we know about the capacitor plague of the early 2000s that affected PCs. This was a different one, but it affected these SMD caps really badly. And I bought one of these packs new in a box, back about 15 years ago, perpetually for about 3 years. They were being flogged by someone in Japan for about $80 each by a Sega pack. It's crazy to think about today. But this hardware all used to be dirt cheap.
Yeah.
Um, I bought one of those new in a box, and yeah, they were all leaking and required a lot of rework. So even if they'd never been plugged in, these were brand new packs, they leaked. It was obviously a manufacturing problem with the capacitors that they bought around this time, and that's the thing that people have the most problems with. But the players themselves have their own whole different suite of reliability problems. Like to give you an idea of how much they squeeze the cost, they've got these different boards that are connected, and normally you'd have a nice socket with a crimped cable that would connect these two boards together, and that stuff costs a little bit of money, not a huge amount. In the LaserActive, they actually soldered ribbon cable directly between these boards to really try and squeeze out, to really get that cost down as much as they could. But I've had
Jeez.
lots of problems with mine with dry solder joints or cracked solder joints because this thing has vibration, it moves. And when you've
Right.
got hard, solid connections like that, that are subject to vibration, they're going to fracture, and that's what happens. So,
Ugh.
yeah, the players themselves, despite being some of the most powerful LaserDisc hardware ever made, and they really are very powerful, they really tried to squeeze the price point of this player down as much as they could. But some of the cost of the components they had to use to make some of the stuff work just made it expensive.
And just to put things into perspective, I think my memory and my math is correct in saying that in at the time of release of the LaserActive, you could buy a Genesis, a Sega CD, a 32X, and a LaserDisc player for about the same or even a little bit less than just the price of the LaserActive and the Genesis pack. I
Yeah,
think that's correct.
I'd
So
have to go and check, but I could believe it. Yeah.
yeah, that's that's a hard pill to swallow, and I almost if somebody's spending that much more money, I almost wish they charged an extra $50 a unit and made it, made it the robust piece of equipment it should have been for that kind of money.
Yeah, I really think they must have had an idea, I think, of making this a premium player, like because they were obviously the thing that really killed this was the demise of Laserdisc, right?
Right.
you know, in their mind, they were trying to produce the best possible Laserdisc player in terms of features, and the digital memory buffer gives advantages for movie playback as well. Like you can have perfect still frame on CLV discs and things like that. Things that were only possible on a very small number of players. So I think they had the idea that this is going to be marketed as like a preem kind of like, video file quality like machine, which they've squeezed the price down as much as they could. And, that did lead to reliability problems, but they only come up, you know, 5, 10,
Yeah.
15 years later. So you still can move your units. But because because Laserdisc, sorry, lost the war effectively, you're then stuck on that wrong side of the format divide. But they had some interesting things they did. I mean, reach for this here now. You know, they have 3D goggles for this unit, right?
That is so awesome. How are they? What are the games like for them? I mean, is it fun? Is it kind of gimmicky?
you
Like
know,
the Master System 3D games, Maze Hunter is amazing. Space Harrier's cool, and Missile Defense, of course, 8-bit 3D missiles
yeah.
flying at you. But there were some very gimmicky ones that kind of just give me a headache too. So where does this kind of fall? Are there any games that are really worth it?
I'll be honest, I haven't actually tried them yet, but they're not really. They're only two games, and the reason I haven't tried them yet is because they're not really games. One's 3D Museum, and it's like, kind of just showing you like footage and in 3D, and the other one's like a documentary thing called Melon Brains. It's a thing about dolphins, but that disc is warped, so I have trouble playing it, so I haven't been able to try that part properly. But it does feel very gimmicky. I think they hoped that this system was going to be a big success and then they'll have all kinds of exclusive titles. But of course, the 3D goggles themselves are another price add on top of everything. So if you're a game designer, you're going to ask, who's going to buy all this stuff and the 3D goggles? And do I want to build an entire game around that? So that probably didn't help them in terms of developers wanting to take that leap. But they're shutter goggles, so I mean they're not just stereoscopic. They're actually you keep color, but in 3D, and obviously the potential was there for them to do lots of things. But you know I haven't got around to emulating that yet, but it's probably going to require you to have spend use a VR headset or something like that to support it properly, you know.
Right.
Um, but yeah, but it was definitely trying to capture, I think, that premium, kind of, video file, someone who has plenty of disposable income and a nice big TV for the day and an impressive home theater system, and this would have been like a crowning jewel in that, where they can also have their games attached that the kids can play, So I think that's kind of the market they were going for. And who knows, maybe if things had gone differently with format wars and Laserdisc had kind of, beaten out DVD and become a really popular format, maybe fortunes would have been different for them. It's really hard to say.
Yeah, and looking back at this stuff, it's crucial that you put context in mind, which I didn't when I did the live stream with it. The first 20 minutes of the live stream, I was just a grumpy old bear making negative comments, and by the end of it, I realized like, wait a minute, I'm looking at this from somebody who's got a lifetime of experience with the entire generations of video games. Essentially,
Mm,
if I put myself back into the 90s, I'm not looking at a pixelated 5 frame per second, barely could see it, relatively speaking, FMV movie on Sega CD. I'm
yeah,
looking at a full screen 480i video. And on top of that, at the time, I without a doubt would have been using composite video, maybe even RF, depending on what family member's house I was over that weekend. But so this would have been like the utmost experience for me. And it actually wasn't until I started digging into uh, really hard into tape transfer in the past 3 or 4 years that I realized how lossy a format VHS actually is. So today, when you have an Ultra HD Blu-ray player and a 77-inch OLED, you go back to Laserdisc and you're like, well, this is stupid. But you put it into context of like
yeah,
what you had back then, you know, that would have been absolutely a noticeable jump in quality, especially if you had a semi decent TV to look at it on. So
yeah,
having all of that in mind when you talk about this stuff, I mean, that really was a premium experience and a pretty cool way to go about doing all of that stuff,
yeah.
even if it was 30 frames per second in most cases, I guess.
Yeah, and that's the thing. It's really easy to, unless I think you grew up in the '90s period and you knew what those TVs were like. We forget how, you know how kind of inherently, grainy and everything was. Like, your TV was usually, not very big, right? Unless you had a lot of
Yeah.
money, your TV was usually like, like that. And
Yeah.
you were paying, as you said, playing games over RF. I played my games over RF. Like, the Mega Drive itself expects, bleed. A lot of games use dithering effects by just literally having pixels adjacent that are completely different. And on the TV, that blended to be a nice, smooth, even color. And when people pay on emulators, that's why we need to have shaders and, like, have filters and things like that to replicate some of the screen effects, because the screens were not displaying these perfect kind of like rectangular pixels we're used to seeing on our screen when we emulate them today. They really did have a lot of interesting artifacts. But in terms of quality, like Laserdisc, I've come to appreciate more and more as I've done this, just how good Laserdisc video could be. And frankly, the Laserdisc titles don't show them off very well, the LaserActive titles, because a lot of the video was not properly prepared for mastering purposes. Like, often, if they've used footage, like real footage, they've shot it on some low end camera onto tape and then transferred it onto Laserdisc. So you've already lost a lot of the quality. Or the digital frames that could be prepared better. In some cases, they've gone through format conversions that have just kind of just messed with their detail a bit. So, the Laserdisc video, if done well, was undeniably the best quality video you could get at the day for a long time. For a long time.
Absolutely.
Yeah.
I mean, there is still a couple of scenarios in which it's the go-to, but that's all down to the transfer. Because
Yeah.
one of the many many projects I'm knee deep in now is Star Trek Deep Space Nine. Even though I never watched the show, I was kind of fascinated about the group of people who were going back and trying to remaster it. And then found that the DVDs were mastered wrong, which is
Hmm.
why they have a green tint on them. But not only just that, there was other transfers like Teenage Mutant Ninja Turtles. The DVD looks significantly worse than the laser discs,
Yeah.
but so there's a lot of history behind that and a lot of money behind that. So while we're talking about cost of the laser active, I mean, I think if we had this discussion in 94, 93, or something like that,
Yeah.
we would have been excited about it and wishing we could afford it, not going, the heck.
Yeah. Well, I mean, I can't. Laserdisc wasn't a thing where I was when I grew up. I mean, maybe it was different in the states, but I never saw a Laserdisc in my life. In fact, the first
I
time I
didn't
think I
have rich friends, so I never
no,
saw one
the,
either.
the first time I actually heard about Laserdisc was probably when I heard about the LaserActive, because I was, a big fan of Sega, and I got down the rabbit hole looking at all their crazy hardware variations, because Sega had a few in the '90s of really strange hardware crossovers, like their karaoke Sega Saturn and the Boombox Mega Drive CD,
Yep.
how you pronounce that, the AWA Mega CD. And I saw this unit. I thought, what on earth is that? Of course, once I
That's
knew it
funny.
existed, I had to have one, right?
Yeah.
And, I picked one up. It was $200 on eBay back in about, I don't know, what was it, about 2000 2005, 2004. I can't quite remember. I figured it out and I wrote it down, but I've forgotten it again now. But that was back in the age when you could get things, because I live in Australia. There were none of these units over here because they're all NTSC. We use PAL over here, right? And the LaserActive was NTSC only. And an interesting point, it could only ever be NTSC because
Oh, I didn't know that.
LaserDisc LaserDisc formats are different for PAL and NTSC. And originally, there was no digital audio. It was
Hmm.
analog video, analog audio. And they revised the spec about 5 or 6 years after it came out to add on this Redbook CD digital audio track, which the LaserActive relies on for the game data. But because of choices around frequencies, they could, because it's RF composite video, you've got things kind of modulated together. There was free space in the bandwidth in the NTSC encoding to add in that digital audio track, because actually the NTSC video is lower quality and power, it uses smaller bandwidth. There was more room in the layout they used, but in
Yeah,
PAL,
Simon lets us know that every chance that he
there
gets.
you go.
Sorry.
Well, I mean, I grew up without NTSC. PAL superior. I'm just saying it's better. But what it meant for Laserdisc is that they were able to just add in that digital audio into a space of the spectrum they hadn't used. In PAL, they did not have that room. So if you add digital audio, you lose analog audio. And so for the LaserActive, for most of the games, that kills them. They're dead in the water because a lot of the games rely on the fact that they can have multiple audio tracks. Often they use it for, one channel for Japanese and one for English, so it's really mono when they put it to both speakers. But there's parts of games like Myst. The Myst games use a lot of overlay video. They actually use the frame skipping features of the player, where literally what they do is they seamlessly jump over every second frame. So they have 4 video streams overlaid, one in one field, one in the other field, and then in every second frame, another stream with one in each field. So they end up with a quarter of the frame rate, but 4 video streams overlaid. And they use multiple audio channels. They'll use the digital audio left, digital audio right, analog audio left, analog audio right. So you have actually 4 separate video streams, 4 separate audio tracks. But a lot of these games would not work if they lost the analog audio entirely and just had the digital. A couple of them would, but most of them use those features. So
Wow.
yeah, so they only ever made an NTSC version of this player. That's probably the main reason why, because it would have, not been as good for gaming. And frankly, the PAL market for laserdiscs tiny, right? Because back in the early 90s, a lot of countries that had PAL were not the countries that could afford a unit like this. To put it frankly,
Hmm.
that's one of the reasons why I think Laserdisc did not do as well in PAL regions, despite it being just as good a format for video. Money talks, and there was the NTSC regions had more of the spending power to buy a unit like this at the time.
Hmm.
Yeah,
So, I guess let's swing back around. And you were saying that you had started reverse engineering the hardware, which wasn't even the hardest part, and then
yep.
you needed to get the actual games and the data. How did that all come about? I mean, was there any way to try to play these games before Doomsday, or was there? I mean, can you kind of start us from there
Yeah,
now and
there's
go?
a long journey on this. So,
Oh,
in 2009 is when I first started looking at this. And in my mind at the time, this is how I thought it was going to go. I'd reverse engineer the hardware. I'd figure out how to extract the digital data.
mhm.
I'd use the player to help with that. And then I would use an analog capture device to capture the audio and video, right? Sounds straightforward enough. So figuring out the hardware was, I mean, it has its own journey. Let me walk you through that. So
Mhm.
figuring out the hardware looked like this. We have effectively it was a Sega Mega Drive attached to this console, and it can obviously talk to the hardware. the whole point is it's running these games. These games have code. The code is running certain instructions that are telling the hardware to do this or that, seek to this location, play this video. All the kind of control over the player that the game can do could obviously done from the game's code. So me knowing a fair bit about the Mega Drive, having done my emulator for it and spent a lot of time reverse engineering it in previous work, felt very comfortable running code on a Mega Drive. So I thought, okay, let me run some code on this unit and see what I can see. And so just like on a Mega Drive, you can use a flash card. So I've got here
Mhm.
an old Sega EverDrive. Though of course it wasn't this back at that time. It was a old Tototech parallel, one that you used before we had the nice USB ones and ones that take compact flash, but or SD cards. But basically, I wrote some code that could run on hardware that could start, kind of probing for what was different. And I knew from a kind of a cursory look at the BIOS, because the BIOS had been dumped, but it's nice and easy to dump on these systems. Um, Approximately where the new additions to the hardware were. So the addresses that were being talked to make it do things. And so I just basically wrote some code and started probing them. One of the challenges with that is how to actually get access to that hardware, because on the Mega Drive with the Mega CD, you've got two different processors. One can talk to the Mega CD side and the CD controller itself. The other one's the main area that runs your code for the main processor. Because the Mega Drive for the Mega CD is quite a complicated system. You've got three different processors and a couple of different sound devices, and all this kind of stuff going on. So what hadn't been done had much done at that point was running games from cartridge that could actually use the Mega CD hardware.
Mhm.
And there was one commercial game release that I know of called the Flux cartridge, which was like a almost like a uh, if you ever played, Winamp with the graphical visualizations back in the
Yes,
day,
yeah, yeah,
kind of
of
making
course.
pretty pictures as your music plays along, right? And so it was a cartridge like that that did it. But around the same time I started thinking about looking at this, someone else on one of the forums I was on, the Spirits Mine forum, had been looking at what is called Mode 1 CD booting, where you use a cartridge to bootstrap it. And by talking with him and muddling out together, we were able to make a cartridge that could bootstrap regular hardware, but also the LaserActive hardware. And so once I had code that could bootstrap the hardware, I could then just basically probe and do whatever I wanted. And efficient, um, to make that efficient, what I did was write a program for it that allowed me to kind of just manually control the register block and send writes to it.
All right, we're back. Sorry about that.
That's okay. I'll just continue in.
Mhm.
Okay. So yeah, once we had the ability to run code on the system, I just basically wrote a program to make it easier to figure out what it did. And so I wrote a little program that allowed me, just using my Mega Drive controller, to it display all the different output registers on the screen. I could literally just use the controller to kind of change values of the registers, just write directly to this hardware interface and see what happened. And just so by messing around with the Mega Drive controller and just banging values into these registers. It's like, oh, I do this and the drive tray opens. I do this and it closes again. And oh, I did this and the drive, seeks to somewhere, and did this and it started playing. And this messed with my audio setting, like changed the audio track selection. So basically, you pretty much just screw around with that for a while, and just I have a pretty strong opinion around the way we do emulation. I think that a lot of people set out to emulate the games. I think that's the wrong way to do it. When you set out to emulate the games and you don't think about the hardware and you're just looking at what the games do and you're building the hardware around what that needs, sorry, the emulator around what that needs, it kind of becomes this very slow, long process where you're just chasing, oh, in this game, this bug happens. In this game, this bug happens. Oh, this game needs that feature. Let me go and implement that. And if you're more focused around the hardware and you figure out what the hardware does in every case, doesn't matter what you're supposed to do. What does it actually do when you do this, right? It's like, oh, the documentation says you're supposed to use this and this, but not use this with it. What happens if we do? Let's just find out. And so I said about emulating the hardware. I basically ignored the games. I didn't care what the games did, because my point was, if I understand exactly what the hardware does and all possible ways of messing with it, and I emulate that, the games are just going to work, right? That was
Mm.
basically the idea. And that's one of the reasons why I bought the hardware actually to start with, because I was at that time quite interested and involved in emulation and reverse engineering, and I saw the fact that a lot of people who are writing emulators didn't have the hardware, you know, and it's this mismatch where you have a lot of people who are collectors and stuff who have all these different systems and all these different games, don't necessarily have a clue about emulation, but they're interested in them and they collect them all. And then you have the emulation guys who are usually we're a bit miserly. We don't want to spend much money, and we're we're doing things on a shoestring budget. We might eventually pay for that flash card if we really really have to. You know, and ultimately, a lot of people who had the skills to build the emulation and to actually move the hardware reverse engineering forward often didn't have the hardware, and they're stuck looking at trying to reverse engineer games, reverse engineer BIOSes, and figure it out backwards. And so that's one of the reasons I bought the LaserActive. I bought it when I had no use for it at the time. I bought it to bank it, knowing that I'm going to want to look at this one day. And right now I can get it for pretty cheap. And that's not going to be the case forever. So I'm just going to grab this and shove it in the box in the corner. And that way, when I want to look at it, it'll be there. And so I've done that with a lot of things over the years for the purposes of hardware reverse engineering. And so when I go around to the LaserActive, I was just able to test on the hardware and just bang things at the hardware and see what the hardware does. And I documented all that, and that became, basically my blueprint for, okay, this is the interface to the hardware. This is all the actual game code can see. This is all the BIOS can see even. So if I emulate this little thin strip of registers here, this block, that is the LaserActive as far as the game side is concerned. If I make that work, the games will work. And so that's basically what went into reverse engineering the hardware. And that worked
Mm.
pretty well. That went pretty smoothly. And there were a few things I didn't quite get to in my notes back 15 years ago that I finished off, more recently as I actually started writing this. I didn't bother to reverse engineer some of the details around audio mixing and video mixing because I had enough of the basics there. But at that point, the rest of it was still a pipe dream. I just kind of put that to the side. So I'll get to that later. But back in 2011, when I first started writing some code and actually try and move this forward, um, yeah, I had written a program to reverse engineer the register block, and I did that. The next step was the digital data, and this is where I actually started trying to rip the discs. And yeah, somewhere around that time, I don't have the timeline from me. I did a timeline recently to try and figure out what happened when, because until I went back and wrote it down, I was like, gee, did I do all that stuff? I've forgotten half of it, right? It's been so long, because I feel like for me, I started this over 15 years ago, and there have been so many kind of detours and wrong turns, things that hit at dead ends, and I had to backtrack and do a different approach that, until I wrote it all down, I've forgotten a lot of it. But um, what I did is on the Mega Drive, on the pack module, you've got the two different controller ports here, A and B. And so you can actually do quite a bit with these ports. These aren't just to press buttons on the gamepad. This has a full a serial bus protocol in there, and you can just stream serial data over it. And a guy called Mask of Destiny, who's involved in Blastem, the emulator.
Mhm.
He's someone I've known for a long time in the community, and he did quite a bit around that time around transferring data over the control port, and Crix, who did the EverDrive stuff back in 2007 or 8. He made a little. I'm just going to grab that actually. 1 second, I'll be right here.
Yeah.
This is a forgotten piece of one of his early inventions, a Sega link unit, which is a USB link device. One of his earliest things he did, I think this has a date of 2009. There you go. I used that to effectively bridge the serial port functionality from the second controller port to a USB connection, and I wrote my own code to drive this unit, and I wrote my own code on the other end. And I was able to just kind of stream data off from the unit as I needed to, and it wasn't fast enough to keep up with the data rate. But by time of taking the data in strips, I was able to take off. I play back the disk, for example. I think it was 8 times, slightly
Mhm.
overlapped. I'd have these little strips of data, and then I'd stitch them back together to make the complete image. So back around 2000, yeah, 2011 or something around the time, I posted what was the first rip of the digital data of a LaserActive game onto this nerdy forum I was on with a bunch of emulation nerds called Sprites Mind, and I did some more work on refining that to get all the subcode data off and things like that. And then I do a bit more work because um, anyone who's familiar with CD formats will know that we don't really actually capture the lead in usually, which is where the table of contents comes from. If you have like a bin queue type image, the queue file is really a hack to make up for the fact that you're missing the lead in. And it kind of tells you what the lead in would have told you in terms of what tracks are where and that kind of detail. Well, to get that off this unit, I had to go to quite extreme lengths, and I had to solder on a bunch of taps to the different lines. I used actually a logic analyzer to capture a streaming kind of capture of what was coming out of those lines while the disk was spinning up. And then I actually wrote code to break that down, reconstruct the data, and then produce me the lead-in information that was missing.
Wow,
So
that's a very cool trick.
yeah, it was back at the time. It was just when this kind of stuff was becoming possible because we had USB 2.0 now, and we could do faster data transfers because back in the age of USB 1.1, there was just no chance. But back in the days age of USB 2.0, you started getting streaming devices. And you could do continuous capture. You weren't limited to like a 64 kilobyte buffer of we've captured things for once. So the old Saley logic analyzers. I got a few clones of those, and then we'd use those to capture some streaming captures, and they'll come up again later. But yeah, so I actually had a full digital dump of the games back in 2011, 12 ish, and I could do that repeatedly for the other discs, but I didn't move on doing that until I figured out the audio and video side.
Mm.
And this is where things get really messy because I thought, okay, analog video capture, it's known areas, doesn't sound too hard. Let me get a few analog capture cards and have a go with it. And it went really, really, really badly.
Yeah. If
It's
you
one
had
of,
asked me 10 years ago, I probably would have thought, yeah, this is going to be more complicated than you expect, but it's doable. And
yeah.
now, after everything I've learned in this real deep dive that I've been in, I can't believe that you got anything working at all. So props to you.
Yeah, thanks. Yeah, it was one of these things where I think people have the illusion that just technology keeps on getting better and better, and that's not true. Sometimes older technology is a lot better than newer technology, especially when it's dealing with problems that aren't really that common nowadays.
Right.
Dealing with analog video was the domain of the past. When we
Hmm.
turn into the new millennium and everything's starting to go digital, no one cares about analog anymore. At least not the people building proper hardware and high-end systems. They don't care about analog video anymore. And so, but there's because of the time mismatch here. By the time computers themselves are at a point where they technically could capture analog video at really high quality and do it really well, there's no market for that anymore because
Right.
everyone has their DVD collections, everyone's moved on. Professional high end video gear doesn't care about analog anymore. They're not capturing composite video anymore, you know.
Right. And while they absolutely could whip out some chips with technology of today that would be way better than anything else, they'd have to make them in quantities of
Exactly.
500,000 for it to be even worth going. And there's not 500,000 people in the world that want this. So there you go.
Exactly. So I had a few attempts at doing it, and I'll tell you what went wrong with it. So there's a few different layers of it, but the biggest problem comes back to the nature of what's on these discs. All analog capture devices were based around capturing video. Okay. And capturing NTSC video is 480i signals, and you don't care about it being perfect because it's coming from analog, right? Analog isn't perfect. So what they were all trying to do was get you a good looking picture of your capture of your analog video. But as I've talked about with Mist overlaying those four different video streams, this causes some problems because these two different lines on 480i, you're interlacing these together. So literally, you're half a scan line offset to kind of make a double resolution picture. That's what they're thinking of. So we think we've got one picture with odd and even lines being mixed together like that, and they'll treat it as such, and they'll say, okay, well, hardware even at the time in the 2010-11 period couldn't really keep up with saving that in a lossless format because
Mhm.
disks weren't fast enough. Even if your hardware was fast enough, even your buses were fast enough, we were still dealing with platter drives, and you wouldn't have been able to stream this data to disk at the right rate. So everything was compressed, had to be compressed, and it was all lossy compression to different degrees. And so when you're trying to produce a lossy compressed image and you have what you believe are adjacent lines, well, everyone can kind of imagine what happens if you start, you know, doing compression across those lines. Those things are going to blend together, right? Because they're
Right.
expected to be the one image. And just like JPEG loses some detail and creates some kind of blockiness and artifacts, and MPEG does the same. It's trying to think that these pixels are all connected. Let me approximate what these pixels look like together. And what would mean is these different images, because the laser active can pick out one or the other and line double them effectively from your perspective, but it just display them normally, really, but it causes them to bleed together. So you can make a capture of the disk, sure, but you can't strip out those different images. They've actually been destroyed. The separation between them has been destroyed. And the exact same thing between frames. When frame A and frame B is different, all video compression formats compress across frames to get them to get the file sizes down. And
Right.
so when Mist is using frame skip, and other games do this as well, it's using frame skip, and every second frame is a different image, like they're being skipped over on the player. Well, those frames are going to bleed together. And so
So you would have had to have used a lossless codec like Lagarith or just full on uncompressed and a
yep,
true 15 kilohertz capture that captures each field separately.
yep.
But then you would have to capture it in one format, separate it in another, post process through all of this, which you could have scripted a lot of it. But we're talking about stuff that's hard to do today, let
Yeah.
alone 10 years ago. So, or 15 years ago when you started.
Maybe the hardware did exist somewhere, but I couldn't find it. The
It
best, the,
definitely did, but we're talking about $2,500 capture cards,
yeah.
we're talking about PCs fast enough, and I'm sure there was a combination of stuff that you coulda used that would have been cheaper, but
The
who was doing that that could reference all of
Yeah.
this back then, you
The
know?
most capable card I had was a high-end Canopus system that it did the best job. It could solve the problem of the frames bleeding together interlaced. I could actually compress to half EUV and solve that problem, not lossless, but I could solve that problem for the individual fields. But I could not solve it for the frames. And the additional problem was the VBI data, the vertical blank interval data. So um, this is the kind of place where I'd normally point to a picture or something like that. But if you've ever seen um, you know, a raw NTSC frame, 525 lines, it literally is, kind of like a squashed image at the top, which is your even field, and then a squashed image at the bottom, which is your odd field, or the other way around, I can never remember. And then there's a small strip above each one, which has some kind of black and white bars. And those black and white bars are control information. And
Mhm,
that's how the Laserdisc player knows which frame it's on. It's how it knows, if it's in lead in or lead out. It's how it knows things like picture stop codes that tell it, stop at this frame, please. And that data is different for different formats. And so, all kinds of analog video existed out there, but Laserdisc video had its own control codes because it has things that only make sense on Laserdiscs. Frame numbers and CLV tiles had time codes, but it's information that's relative to the format, and they use different lines in other medium. So every capture card I could find that had supposedly support for capturing VBI data, they weren't trying to capture it as an image. They just wanted to decode the data and give you the data out. But it was all based around different standards. And so it wouldn't capture the right line numbers, it wouldn't capture in the right format. And those control codes are important for emulation. So I even went down the rabbit hole of thinking, okay, maybe I can still make this work. I'll use a delay line and separate the the vertical sync, but push the graphical lines into the display region for the vertical blank and capture it there and then stitch it back together. I actually went a fair way down that rabbit hole of try and make that work, because I really wanted to get over the line back then. But what I found increasingly as I went down is that I can probably make something work, but it's not really going to properly preserve these discs. And we just have to go back again and archive them all again later. You know what I mean? I feel like maybe I could make some games work, cobble something together, which will have, okay, but not necessarily great video that'll kind of function. But I reached the point where I kind of thought, is that going to help preservation of the system or harm it? Because if I get some games out there that kind of work, that I know it's technically not very good, it's just going to kind of pour cold water on the enthusiasm to actually get it done properly in the future. And these tiles are so rare and hard to get in some cases, they'll probably never be redone. And some of these games will then be stuck with inferior quality rips forever. So, around that time, around that 2013, 14 periods, when I said, look, I know what I need to do, but it just doesn't seem like the hardware exists, or at least I can't find it. I probably need to just put this on ice for a little bit and reevaluate, see if things are going to evolve. Keep on researching capture cards, keep on researching techniques, but not try and rush to get something out there that I know I'm not going to be happy with.
Mm,
So that's basically what I did. And then not long after, this thing called the Doomsday duplicator started being talked about and coming along. And I followed that from a very, very early phase. You know, in its infancy, it was definitely not there yet. It was a great idea, but it took
right.
time. It took time, and it was good they had the momentum and the drive behind it. They had a lot of people come on board with that project and help out with it. Because this is something that I've learned over the years is that you can be smart and capable, but you're only one person, and some of these problems are too big for one person to tackle. You really need a community effort. And for me, I think, the Doomsday Duplicator is a great example of a really good community effort where you had people come out of the woodwork, experts in signal processing and like analog signal processing and things like that, I could read every book ever written. But when you've got a guy who's done this for 30 years and worked in high end systems and built it, who has the experience, that can come in and actually give that guidance and help directly influence a project like that. That's what these things need, right? Sometimes it's just, people who actually know this stuff from lived experience who can give some feedback. And you know, I built some of the earlier versions. I got one down here. What's this Domesday Duplicator 2.0? I think. I was building this right from the early versions and playing around with it, and it had a lot of promise. The the capture side took a while to get there,
Mhm.
and I started messing with another idea when LD Decode was still young, and this whole idea of decoding laser discs from the RF was still young, because at the time it was unproven. It was still unproven. It was looking good. It was looking promising, but it was still, are we going to get the same quality? Are we going to be able to make this work? And so I started messing around with my own video decoding approaches, because um, what I did was inside the LaserActive, there is a chip that does the actual video decoding, where they've already separated the different streams. So we've already peeled off the EFM data for the city audio, and that's over there. We've pulled off the analog video, the analog audio. We've got the analog video, and we're going to pump into this chip, and it's going to actually turn it into a digital data, because this has a digital frame buffer. It had to turn it into. It can't just pump it out to the composite output to your TV, like a lot of players did. This has to go through decoding circuitry, turn it to actual digital data, so it can store it in a digital memory buffer. And it produces an 8-bit effectively RGB output from that. Well, not RGB, sorry, let me rephrase. It produces an 8-bit um, um, no, I'm remembering wrong. Rephrase. The chip takes in a composite input, which is turned into an 8-bit format. And Domesday Duplicator works at 10-bit basically,
Mhm.
but this was working at 8. But this is after the demodulation, so it didn't have to have the extra bandwidth to deal with that. And so that I had an idea with, what if I just take um, that 8-bit data, stream it over effectively like a logic analyzer, like I did for the data, to get a continuous capture, and try and decode that in software. After all, the time was like, say, 2014. decoding video and software. Surely we've done this stuff by now. Not really. LD Decode was really the first attempt to do it. And I started looking at it before LD Decode came along. I was like, oh my goodness, they're doing the thing I want to do. And so I had a crack, kind of like almost like in a parallel effort to Doomsday Duplicator, kind of saying, well, if that whole decoding the RF thing doesn't pay off, let me just hedge my bets and try a different approach. And so I tried to work on just decoding the composite video because I could get a streaming capture without the Domesday Duplicator hardware, just using a logic analyzer. I could get that analog waveform, but I couldn't decode it. So I thought, let me have a crack at doing that. And my own efforts at the time got pretty far along. I was able to decode video. It was a bit more. It was a lot faster than the LD decode pipeline. Like I could decode not at real time, but not far off. And I
Mhm.
could get, I could lock onto a wider range of signals because LD decode was looking at laser discs specifically, 525 line, like interlaced NTSC video. Um, I want to be able to work on, a bit more flexible signal sources. I want to be able to capture, for example, just composite running at 240p, things like that. I found LDD code in the early days was very, 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 very particular. It wanted a very narrow set of specs. It wanted to be able to deal with exactly that. I was just saying, okay, can I just solve general composite video decoding and make it work? And I got pretty far along, but what I discovered doing that process was that, yeah, keeping a signal lock on the color burst, getting that part right, the phase locked loop thing that could be done in hardware, like analog hardware, using just a few basic components. Doing that digitally was really, 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 really hard.
Hmm.
I had color drift problems where it just wouldn't quite lock on, and I could just see comparing A and B. I could decode the brightness, the luma, fine, but getting that color reproduction really spot on was really hard. And as my own efforts I kept on kind of going around and around and around doing that. My time just started dropping off, just personal commitments, work life commitments. And I just really felt like I was not making significant progress. And then at the same time, LD Decode and Domesday Duplicator were just tearing along, just making good progress every single time. And so I said, well, look, life's getting in the way. I'm kind of really seeing that my efforts here aren't going further and their efforts going really well. I'm going to take another step back and just let this mature a little bit more
Mhm.
and keep on building the hardware variants as they come out, keep on testing them, seeing how they're going in the real world with trying to capture this stuff. And so I did that for another couple of years and I swung back around to it. I said, right, where are we? And, the LDD code and Domesday Duplicator had solved most of the problem, but still not all, because they were, again, similar to the capture cards of the day. They're trying to capture video. You know,
Mhm.
that's really what they're trying to do. I'm trying to capture the full 525 lines of the NTSC frame with all the VBI data, whereas they kind of, in their post processing, they'll carve it off and crop it to the visible region.
Just
They'll
to
de
interrupt real quick
go for
and
it.
clarify what you're talking about. So the Doomsday project has always been focused on getting the full rip of the disk with everything on it. But you're right, the software processing side started out, of course, for the first couple of years on the video content. But the
Mm,
Doomsday project was always focusing on getting everything. It just, not enough hours in a day and
yeah.
not enough people working on it. But so
Few-
I didn't
yeah,
want
yeah.
people to get confused by that. But
You're
continue
right.
on.
You're right. Yeah. And there's a few caveats though. What does
Mhm.
everything mean, right? And this
Right.
is this is one thing. Like when you take a backup of a CD, you might say we're backing up the whole CD. Well, you're not. You're backing up part of the CD, and the bits we don't have, we think are the non-important bits.
Mhm.
Domesday Duplicator does a full RF rip, and that is really good. It has everything on there. The question is, when you go down decoding it, do you extract everything? But also, what about
And
the
how do you
lead-in?
even know what it is? How do you even know what
Yeah,
you're trying to extract off of it?
but also, what about the lead-in, right?
Mhm.
So the lead-in contains the table of contents. Well, as I understand it, the Doomsday system didn't need the table of contents data. The LaserActive does. And just like a CD, there is this section before the video kicks in, before frame one, that contains data. And that data in the video stream, it's the TOC data for the video, and in the digital audio stream, it's the TOC data for effectively the CD that follows. Um, no one was capturing that, and there wasn't a really good guide on how to capture it. So I had several problems to solve. One was I needed to know how to capture the lead in reliably for a LaserDisc. I also just want to capture the lead out, just because. Let's just capture the whole damn thing. Let's not restrict ourselves to just what we think is the important part of the disc. Let's get the whole thing.
Mhm.
And so I wanted to figure out a way to capture every single bit of that spiral that's been written on that disc from the very beginning of the lead in to the lead out. That was one of my goals. Then decoding side. I need to be able to decode it not to a pretty picture, but the raw 525 lines of NTSC video, full width, full height, everything exactly as it was. And then, I need to be able to store that in a form that's appropriate for emulation. We'll get to that later. And so what I did was I spent quite a bit of time messing around with the players themselves, and I figured out ways using test mode and some obscure commands and things like that to actually get into the lead in, play through the disc, and that's the important part of what I'm going to talk about in a second. Play all the way through the disc, play into the lead out, and then ultimately reach the very, 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 very end of the track where literally the player can't follow the spiral anymore because they've gone off the end of the disc or the
So
spiral
essentially, what
stopped.
you're trying to get it to do, and please excuse this
Yep,
very rudimentary explanation, is imagine a vinyl audio record.
yep,
You want to take the needle and place it on the microscopic edge of where it starts
yep,
and have it go all the way up to and hit the label and stop right as it hits the label.
absolutely. So let's look
Right.
at the laser disc here, right?
And
Here's
most
one.
players cannot do that, which
Nope.
I just learned probably from you, actually. I think it was your guide, but
Yeah.
continue.
So this is probably not going to come out well in the video at all. But on this disc, there is a section here which is probably about that wide, right?
Mhm,
Which contains the leading information. And it's to allow a nice big healthy margin of error, right? It's to
mhm.
allow a room for when they're actually producing these discs, for the fact that the first little bit's probably not going to be very good as things actually get, you know, when they master this. Traditionally on CDs, for example, when you're burning a CD, well, the laser has to actually start. It doesn't go from not doing anything to instantly cutting a perfect pit. It's actually got to have some time to warm up. So the lead-in allows a lot of time, and even though laserdiscs aren't mastered that way, the lead-in allows a lot of time for things that can go wrong at the start of the process, then a nice big wide generous gap for the table of contents, and then a known start location that will occur sometime after that. So the idea was to capture all that lead-in. And then the same thing on the outer edge, which is the lead out, which can be very thin sometimes. It depends on how much was used of the disk. If the disk is all pretty much sitting at capacity, that can be quite a small sliver. If the disk is only half used, then it's going to be quite a long region. But it was capture all of it. Just, because knowing uniquely how rare some of the laser active tiles are, especially things like the Mist Pros that I have here, we really get like probably one good shot at them. Effectively, once they're in the hands of collectors who don't have the knowledge or even sometimes the willingness to get these things backed up, they'll just sit on a shelf somewhere, and then we don't get the chance to preserve them. So my idea was to make sure that I'm getting every single thing I can off this disc before I have to give them back or hand them over before they go elsewhere. And so so that side of it was really concerning for me because you know we can't make that back. The decoding can improve. We can improve the decoding after a capture is done, and it will probably continue to improve in various ways over time. But I want to make sure that that raw rip from the laser was as complete as possible. Yeah.
And ironically enough, you need specific players that have the ability to do that.
Yeah.
And the average laser active player that most of us know when we think of it in our minds can't do that, which I didn't
Yeah.
learn that until it was too late.
Not safely. Not safely. Because the laser active player, again, was built down to a bit of a margin, it's also a consumer grade player.
Mhm.
The actual player is never going to try and get as close to that inner region as possible. It's going to go to an expected kind of safe region, track back a little bit. Oh, I found it's the TLC data, TOC data. I'm now going to seek to the start position and go there. It's not going to try and move that laser all the way back as far as possible to that inner region. And there's a lot going on there in that inner region. You've got the spindle and stuff, and you don't want things to actually start contacting there.
Right.
the industrial players, like the couple I have behind me, I've got an LD V8000 and LD V4300D there, and I've got a few other players somewhere as well in this room. Um, they they were designed for industrial purposes. They also were designed to be kind of rack mounted into a professional kind of environment, driven remotely half the time by serial, and kind of doing some critical job in a pipeline. Um, and the players were built to a standard that they could have reliably played for 10 years in a row and not have issues. And the actual mechanism that holds the laser on the laser active is kind of like one thin rail, and then kind of almost just sliding along free on the other side. This has a proper strong dual rail system with two nice kind of rolling mechanisms there. It has rubber stoppers at the end, so when you try and seek to that very innermost point, you kind of bounce on rubber. You hit the rubber, right?
Right, which,
It's got a safe
probably isn't
lift.
good, but it's way safer than anything else.
Yeah.
I think that's what I have, the LD, the Pioneer 4400.
Hmm.
I think that's the one I have here. My friend bought
Yeah.
for me to do this, then send back to him. But yeah,
Yeah.
that's the one that I plan on finishing the mod to do exactly this.
Yeah. The LDV 4400. That's
Yeah,
the one. Yeah, and I've got that player here too. It's basically the same as this one, just
different color.
different color. And you get to pay PAL discs as well.
Hmm.
So it can kind of do everything. They're a good player, and so these ones I could safely seek
Wait,
into that
hold
limit.
on. Did you say the 4400 can do PAL and NTSC or just NTSC?
Yeah, look at Simon's pages. You do a firmware swap. The LD
Oh,
4400
okay, okay, okay.
the LD 4400 is basically the NTSC only version of that player. It's basically identical hardware, just minus a few bits. But yeah, with a
Well,
firmware
I'm gonna
swap, you
take
can make
my
it pay PAL.
60 glorious fields per second and just live with it. So you all could have your PAL players. I'll take
I
that
should I
one.
should qualify. I should qualify. I realize I kind of led people astray. You won't be able to play back and get the picture out, but you can play for the purposes of capture.
Right, for the Doomsday direct
Yeah.
RF capture. Right, yeah.
Yes. Yes. To clarify that. But yeah. So yeah, those players are built to have safeties basically. Whereas the laser active, I have several of them here, and I did attempt it with one. The first thing that happened, like when you're going to send test modes, the newer players of laser active, they're very squirrely. When you try to seek in test mode, that thing goes flying really really fast. So you kind of try to gently tap to say, let me get close to the lead in. What happens when it reaches that innermost point is it basically just hits a hard plastic stop. And the very first time I tried to do it on my laser active, what happened was it hit the stop. Because it's on a single rail, the mechanism is slightly twisted and jammed, you know?
Oh,
And I had to physically go in there and like shift and pull it back a bit. And of course, it's throwing things out of alignment. Then by doing it, I've got to recalibrate the player. So I basically said, okay, that player is just not a good idea. Don't do it. you know,
yeah.
you cannot do it safely. But these bigger industrial units, you can do it safely. The the actual mechanism is designed. It's robust enough that if you hit those bump stops, you're hitting at a very slow speed because they seek slower, but it just kind of says, okay, nope, nope, nope. I've reached my limit. I'm just going to stop there. And it still requires a little bit of care, but you can do it. And that way, I can rip the complete contents of this disk. And going to the very beginning of lead in is probably overkill, but you need to get into the lead in and capture a complete cycle of the TSC data to make it a complete dump. And there's also media information on these disks. I add things to the Domesday duplicator project to allow you to capture the user code data. So the Pioneer user codes are on all of these disks, and they actually contain, the full title name, the side, the what's it called, the media code, like the catalog number, sorry, the disk,
Mhm.
how many frames are supposed to be on there, things like that. Some extra meta information stored in that lead-in area as well that is useful. I found it useful for the mist disks, which basically come in like a white box, kind of almost basically unlabeled, and you just have the label on the disk. The media information on that inner ring gave me more information about how they categorize the disk to confirm some details, which made it useful when I'm kind of saying it's this version of Mist because it tells me clearly in the title what it is. But yeah, so um, capturing the lead-in required some hunting and experimenting with players, which was becoming increasingly expensive. One of the side effects of Domesday Duplicator, unfortunately, is that suddenly everyone wanted a LaserDisc
Yeah.
player. It's funny, like the things that used to be so cheap, like here is the
I
reference
was
disc.
just about to say, are you going to pull out the GGV calibration disc? Yeah, they can't even get those anymore
I
anywhere.
I wish I bought a few more copies.
Yeah.
The thing cost me, I don't know, like, was it $100, which felt like a lot at the time for some new old stock reference disc.
Ugh.
Um, Nowadays people want, if you can even find them. I mean, I'm not selling my copy, but let's put it that way. The people who have them bought them for this reason, and they're not going to give them up. And so
Yeah.
finding a copy now is very, very hard, and they're very expensive. And you know, I'm glad I bought some of this stuff like when I did, because it's become very expensive to do. But yeah, the players themselves, I got these players earlier on. As I said, when the Domes UK was in its earlier phases. So I got this player behind me for was $100 on uh, Gumtree, which I suppose is like Craigslist, like a local classified, things like that you know you just don't find anymore. So I'm glad I got those when I did. There are still players out there, but you just got to pay money for them now, big money than you had to before. So yeah,
So let's uh, all of that was kind of crazy. So now we're at the point where you have everything reverse engineered from the hardware side. You figured out how to do the rips. And so where are we at from there? How long did it take you to put it together in a way where it was actually usable in an emulator?
yeah.
And then we'll get to how people could actually use this which is probably a good place to start wrapping up at that point.
Okay, so I'll quickly talk about decoding a little bit more. Decoding
Mhm.
was is still a problem. So the EFM data, the digital CD data. I know that we kind of think that's been solved. We're currently in a weird place where there's like three different versions of EFM decoding. They
Mhm.
all have their pros and cons. I found that in practice, the EFM decoding that we've been done so far for LD decode just was not up to snuff. As soon as it encountered some errors, it would easily just start dropping data, and it would on audio. You don't necessarily notice because by default it's going to pad it with concealed samples, and it kind of just blends into the mix. But sometimes it would actually lose sections, and it would drift out of sync because the data is being lost. This isn't the capture side. The Domesday duplicator was doing its job in capturing the data, but the decode pipeline just was not quite there.
Mm.
And so I effectively started my own work to rewrite that, because I just found that in reality, when I was trying to decode these discs, which, and unlike regular laser discs, are not just an audio CD, these are mixed mode CDs that have data tracks and audio tracks. And I was trying to decode with all the subcode data, which no one else cared about, because who cares about subcode data for your digital audio track for your Star Wars rip? So I was trying to get all the data off, and there was no support for subcode decoding in the pipeline. It was just discarded. So I did quite work on the EFM decoding side to make that work. I did go down a bit of a rabbit hole that I'm probably going to continue on again later, which was decoding of general CDs, because it's something that we don't do very well right now. Is all CD image formats kind of suck. They're all missing data. And I started going down the rabbit hole of, when I was trying to write my own EFM decoder, it's like, well, what do I need? I need more sample data. I've only got so many LaserDiscs here that have digital audio, but I've got a whole stack of CDs. So I just started capturing CD rips and using that to improve the decoding. And so I've got quite a bit of work that hasn't kind of been published or put out there yet, but once I get this whole LaserDisc thing sorted and put to bed, I'll probably swing back around to that and put some more tools out there to do with general EFM decoding. But I know that right now we have the old version of the EFM decoding in LDD code. I can't remember if it's Chad or Simon, but one of them's come up with the new version of LDD code. So the new version of the EFM decoding they've done, like a rewrite that's supposed to be improved. I did my own rewrite. I kind of released a kind of like a beta binary of that. I think some people are still using because it can kind of handle errors better. And so at some point, this stuff has to kind of converge and produce something that's kind of useful. But I'm using my own decoding pipeline right now for EFM, because I just found that for me, that's reliable, solid. And, um, yeah, it's an area that LDD code is not quite there yet. I'm hoping to contribute back to and ultimately get it there. But yeah,
Nice.
yeah. But yeah, okay, decoding side. Let's just say I add my own custom code to spit out the frames in the format I need. I fix the digital decoding, and that's got decoding sorted. So let's shift on to the emulation side. So I said to someone in a Discord chat about a year ago that I reckon it'd take about a month to add LaserActive support on top of a working existing Mega Drive and Memory City emulator. In the end, it took about 2 months.
Hmm.
That's about it. I started with Aries as a base, and I did that probably for a number of reasons, but one of the key reasons was that Luke Usher, the main maintainer on that project, he'd actually kind of put together okay, if we were to add Mega LD support, I'd add this stuff to the system. He kind of put a scaffold together to kind of have a new system defined. It was just sitting there, just said, okay, insert emulation code here, pretty much. And not having worked on the Aries code base before, that made it so easy to get started because I was and still am to quite a degree time poor. I'm trying to fit this around,
Yeah.
work and life. I'm married with 4 kids these days. It's not like when I was a teenager where I could just say I'm just going to skip school for the next 2 weeks and reverse engineer this thing. Where I could pump so many hours into it. Now working a reasonably demanding job and life commitments mean that I'm
Mhm.
squeezing this stuff in a few hours in the evenings or a bit of time on Saturday if I'm lucky. So that made it really easy for me to get started. And also having talked a lot with Near or Bayou as I knew him in the emulation community at the time. I was very sad when he passed, and I kind of felt as a nod to him. So I worked on my own emulation efforts. Like I have my emulator Exodus, but I never did Mega C support. That thing's permanently on ice right now until I have time in my life to do something with it again. I didn't want to I've always been interested in just kind of getting things out there, publishing, researching, letting other people put it in their emulators. I'm not trying to kind of keep it and hoard it into my own little corner of the world. So I want to kind of contribute this in an area where people can actually play it. And Aries is a real emulator that's out there that people are using. I thought this has Mega Drive and Mega C support. Everything's sitting there. Let me have a crack at it. So it took about 2 weeks to get Space Berserker booting and running. And Space Berserker is my go-to test title. It's kind of funny because you talked about having a somewhat kind of cynical view of the system. Maybe it wasn't so good, like looking back on it earlier in our video. Space Berserker is probably one of the crappiest games on the system, if I'm honest. But it's a title that I did almost testing on. And so when I started going through and ripping some of these games, because I didn't take them out of the covers because they're basically pristine copies that I was loaned. I've been discovering the games myself the last few months. I've been ripping them and playing them. I'm like, some of these games are actually pretty good. Whereas I thought, honestly, some of the games are bad, but some of them are actually quite good. And so Space Berserker is the title I started with because it's kind of like, well, I've done all my testing on this. This is the one I'm going to continue and do first. I had that working in about 2 weeks. And it was pretty crude in terms of the way I did it. I spat all the frames to a bunch of PNG files, and I just load them from the folder when I ask for the image.
Hmm.
So the emulator literally at the first cut just loaded. I had the digital data ripped as a CD image,
Mhm.
chuck that in there. Raw PCM as just as the analog audio. I had a folder with a bunch of PNG images. I would literally just say, okay, it wants to load the next frame. Let's go to the next frame in the file system, pull it out, and load it. And that ran. It did run. It didn't run necessarily well. There's overhead from pulling out a million different frames from a million different files like that. It's not ideal. But it proved that the core of the emulation was working. Like most of the notes I'd taken were correct. There were a few additions, there were a few corrections as I went back and tested things on the hardware again because, oh, this thing didn't work properly. Oh, I missed this mode. I missed this setting. You know, but that took, yeah, probably about 2 3 weeks to get that kind of polished off, and Space Berserk was running well. And then because life got busy again, I put it down for about 2 months. But then when I swung back to it, I was able to just continue on and finish it off. And all that really needed to happen was the format. So this is where some people who've tried this stuff will immediately ask, what's this MMI image thing and why is it so big? Um, the answer to that comes back from what we were talking about earlier on about video compression formats. Video compression assumes that you are playing a video from start to finish, linearly, just going through next frame, next frame. And they pipeline everything, and they use, they have keyframes, but they're using frame deltas to say, here's what changed from the last image, and here's what changed from that image. And they're all kind of building on each other, such that you can keep deltas between frames small, because usually when you're looking at a video, only a little bit changes from one frame to the next, right? That's what makes video compression formats smaller than just zipping the thing. Um, Unfortunately, because we have all these different video streams mixed together, it doesn't work well just doing that with the LaserActive, because the LaserActive is not just going next frame, next frame, next frame. It can be seeking around like crazy. And if I was to just play through the Mist stream, you get an idea of what I'm talking about. If you've played Mist, which most people watching this channel would have, that's not a video. that
Right.
there's a bunch of still images and transitions and wipes. And yes, there are video sequences when you've got people talking, but the entire Mist game is on a disc on a LaserActive. And how does that work? It's because they're just treating the disc like it's a frame store. There's just a bunch of images, and there's very short transitions, and there's looping animations as it goes around. The player can do all these things very, very quickly because you know, this disk is spinning around and it has hardware features that allow it to seek forward or backward by fixed amounts during the revolution in the VBlank, so they actually can do seamless, completely instant skipping forward and backward. Some games play backwards. Rocket Coaster, if you give it a go up a slope, then hit the brakes, and you start sliding back down again. That's when the player is actually playing the video stream in reverse.
Oh,
Now,
wow.
yeah. So the disc keeps on spinning the same direction, but at the end of that frame, it actually jumps 2 frames back. And that spins around and jumps 2 frames back. And the effect is a seamless reverse. And
Huh.
so find me a video compression format in the world that will allow me to play the video stream in reverse at variable rates at real time while I'm emulating 3 different processors and a couple of video chips and a couple of sound chips and mixing it all together. And I've then got to overlay the video stream with the Mega Drive video stream. So the problem is one of actually the formats themselves. Video formats are just are not suitable for the way the laser active discs are used by the code. If it's just playing a video and things like Dragon's Lair and stuff people are going to know about on MAME, they're from a whole different age. They're from the kind of early to mid 80s period of Laserdisc players. These were basically completely independent systems. Literally, imagine you've pretty much got an IR sensor stuck on a suction cup on a Laserdisc player that's just kind of sending serial commands to say, okay, now pause, now seek, now rewind, now do this. It was a very crude control. Those players were slow. So when Dragon's Lair, for example, has to do a seek when you're emulating that system, it was okay. The system paused for a huge amount of time while it did that seek operation. Not so in the LaserActive. It had some of the fastest seeking ever done in laser displays, but it also had instant seeking for these various kind of skip modes. And so, effectively, what it means is that video has to be stored without any interframe compression. Every frame is a keyframe. And as soon as you do that, any container format that supports keyframe only modes is still going to be huge. Minimum like 10 gigabytes for this stuff. But even if you can use a 10 gigabyte format for it rather than, say, 30, which is what some of these disks end up being, you can't decompress that fast enough while emulating the rest of the system. And so we have quite a very, very fast, kind of low overhead decompression format we use. It's kind of based on QOI image compression that keeps the thing running smoothly enough. You still need reasonable hardware, because the biggest problem is I/O. Actually, you need an SSD really to play this stuff full speed, because a player drive, again, with the amount of seeking and the amount of bandwidth, often won't do too well. So if you're playing from an SSD though, on a reasonably modern system, you should be okay. There's things we can do to improve emulation speed in the future, but on a lot of systems now, you'll get a full frame rate with that. And people will probably come along and try and improve on this later. I know that I was in talks with someone from MAME for a while about getting what we're required to get the stuff into MAME, but the CHD format that MAME uses, that needs revisions if it's going to be able to support this stuff, and maybe they'll have a crack at trying to get better compression rates while still supporting the performance we need in CHD, and maybe they'll become an alternative for the future. But they're big right now,
So
unfortunately.
what's the file sizes that you're talking about for, an average game at the moment?
Okay, so average, because it is compressed, it can vary depending on the frame content. But let's just say, on average, you're looking at about 30 gigabytes for a single-sided CAV tile, which is most of them. There are the exceptions. The JB Harold title, the Blue Manhattan Blues, it's the largest one I've seen so far. It's double-sided CLV, and they use different frames in each field. So that single disc is holding 4 hours of video. To put that in perspective, so 4 hours of video on that disk, but it comes to be 120 gigabytes. It is the biggest
Wow.
title. I don't think anything's going to beat that. I don't think none of the other discs I've looked at so far are double-sided CLV. There are other ones that are CLV, but they're usually one-sided, or they have CLV on one side and CAV on the other.
And
Um,
are these stored online somewhere for people to
yep,
try themselves?
they
Yeah.
are. They're all gradually being uploaded to archive.org. Right now, they are circulated in the form of torrents. There's links to things from my website right now, but I think the idea would be to get them all on archive.org because of the size of the files. It makes sharing a little bit harder than normal. Some of this
Yeah.
stuff.
And
Yeah.
you need an SSD for this, right? It's not something where you could like burn it to a Blu-ray and then just play it right off the Blu-ray disc,
No,
right?
in my experience, if you're going to get full speed, you need to be playing from an SSD. You can put it in cold games on cold storage on player drives, but the first time you go to play it, you probably get about half frame rate. And then if you go back and it's funny if you're playing a game and it's using a certain number of frames, and then you were the lowest save state from 10 seconds ago. Well, play full speed until you get to that point, and they'll slow down again because your disk buffer, is helping you there. But you know, yeah, SSD I think is going to be required for any solution probably, unless we can get the file format sizes down significantly. But then your CPU requirements are probably going to go up. So it's pros and cons. But
Interesting.
we are aided by the fact that there was a relatively short catalog for this system. So
Yeah.
even though the disks themselves, the captures are large, there is a finite number of these disks. And so even if you're going to get every region of every title for this entire system across both the Sega module and the NEC module, which we probably should talk about a little bit at the end, it's not going to be like, it's not going to be so massive that you have to go out and you know buy a whole SAN system to store it. You're person people who collect stuff like this, you'll probably already have the space sitting there somewhere. Yeah.
So how much of the LaserActive library has been ripped via Doomsday so far?
Yep. So I'm fortunate to have a lot of the tiles here with me.
Mhm.
I'm actually actively in the process of ripping another batch. I've put on 2 batches so far. The third batch should contain the last of my titles, and it covers most of the library in at least one region. We are
Mhm.
fortunate that most of the discs have proven to be bilingual, multi-region, as in the player itself is not region locked, and most of the titles are they just did one game, and
Mhm.
it detects, oh, you're running on the Japanese module or default to Japanese language, you're running on the US module or default to English. So we are going to rip all versions of them for completeness, but it doesn't seem so far that a lot of the tiles matter too much which one we've ripped. There are exceptions, but most of them fall into that camp. There are some titles that are rarer, the rarest one being 3D Virtual Australia, which I'm told was basically almost not released. There's only a handful of copies known to be out there. There's leads on getting that one ripped, but nothing's done until it's done. But I'm very much crossing my fingers for that one because there's very few copies of that we know to be in existence, and that's probably going to be the hard. Apart from the Miss Pros, which are already covered, I was fortunate enough to have those lent to me for ripping. That's the main one we still need to tick off. Um,
So what about
yeah,
the quality of the rip? Is this something where stacking would be able to improve the quality? So
hundred
basically,
percent.
if you're out there and you have laser active games, especially some of the more rare ones, are there people, is there, like a subgroup in the Doomsday Discord or the Ares Discord or something where people are kind of getting together about this? Because I'm going to have this player temporarily for a while, but I would
Mm,
certainly be able to. Well, I'm going to rip the two games that I have, but
yep.
I'm sure there's other people out there, and Speaking as a nerd, after all the time and money and effort I've spent on Doomsday over the years, I would love an excuse to use this hardware a bit more for something a little more exciting than me just messing around with it. So
Yeah.
I'm sure my fellow nerds, a giant chunk of us probably feel the same way. So is there already efforts underway for people to kind of pick a place to meet up, to get, virtually meet up on Discord or whatever, to
Yeah.
get these things coordinated, to get these discs ripped so that we could stack enough of them together to get the best quality out of each?
I'd say coordination needs to be improved. I've had people reach out to me,
Mhm.
directly, and I'd encourage people to do so. Like join the Domesday Discord, Doomsday, Domesday. Cool. Join the Doomsday Discord. Look on the emulation channel there. You'll hit me up. You'll find me there. Same with Aries. I'm on that one as well. But what I have had is several people like offer to loan me the discs they have. Usually, people don't have massive sets because these
Right.
discs are rare and expensive. Usually, people have, oh, I've got these 4 titles, I've got these 2 titles, and if you're in that situation, a lot of these people did not already have Doomsday duplicators in their access to it. And even if they do, most people don't have calibrated players. You can't
Mm.
underestimate how important it is to calibrate a player, because I know that some we've talked about this, but calibrating the players is important. If you're taking a rip on an uncalibrated player, you're probably going to have a large amount of crosstalk and things like that that are going to mean that your rip is already suboptimal. And for stacking purposes, I don't just rip a disc once. I rip a disc 5 times. And I rip them on 2 different players. So there's 2 different players I have back here. I rip each side of each disc 5 times on this one, 5 times on that one. And that's because I want to correct noise on the player itself. So I can stack 5 copies I've taken here. I can then stack 5 copies I've taken there. I can then stack the two together. Does that make sense?
Yeah, so that
So
anytime there's a player related issue, either per rip or per player, when you have stacking, the software will read each bits of each and try to put them all together. So whenever there was a blip or crosstalk or something missing, all of that information fills back in.
yeah, the most important thing are dropouts, right? And that's why we need multiple copies, because the same disk is going to have dropouts in the same places. Multiple copies allow us to correct for dropouts, but noise is a real thing too. If we have a single noisy rip and we introduce that into a stack, it actually is going to degrade the quality of that stack if it itself cannot be corrected. And so uncalibrated players are actually a problem. And I would normally have just said, okay, look at the calibration guide, get yourself a reference disk and calibrate your player. You can't get one anymore. So
Right.
my advice would be reach out and talk to me if there's something you want to do. But in most cases, probably the best thing to do is to send your discs to someone who has a calibrated player. If we're trying to do really high quality archival for all time stuff, we need it done on hardware that was a known quantity, basically, is the
Yeah.
answer. And also the seeking into the lead in thing. You might not have a player that's capable of doing that. And if you do, you might not be comfortable giving it a crack. So frankly, the best thing to do is to reach out. We'll talk about what the options are. I've been coordinating with several people. Some people have sent discs to me. Another person I'm looking at traveling to potentially pick some discs up from, who's based in Australia as well. But yeah, the actual capture process it's not a cheap process to start down if you're not already
Mhm.
set up for it. I wouldn't recommend trying to bootstrap it for a couple of titles. As you've mentioned, it can get expensive, and getting the calibration done right now is virtually impossible unless you have someone who can help you out with it. And the players themselves don't travel well. If I was to try and chuck these in a suitcase and drive to some other state, they're going to come out
Yeah.
the other end. I'm going to have to calibrate them again. So
Yeah.
the discs need to come to the players. Basically, was what it means.
Yeah.
So yeah, but we are quite far down the track. There's 2 different people I'm talking to right now who have access to extensive collections, and we're trying to coordinate logistics and things like that around that. Um, I'm optimistic that if these 2 things pan out, that we will have at least one copy of everything. I think we'll actually have multiple copies of everything, which is enough for us to get a good job at stacking. However, nothing's done till it's done. So keep on
Right.
crossing fingers, and we'll see how it all pans out. Yeah,
Well, so I don't know. This is fascinating because this is all just I've been wondering all of this stuff. And I've been wondering it all before this was even really possible. Like I remember in the interview with Simon and Chad, they mentioned LaserActive briefly, and I just had so many questions. I was like, "This probably isn't the time. Shut up. Just keep going." And they're like, like, so I
Yeah,
did. I kept my mouth shut, and I talked about it a little bit, but I just there were so many different aspects of it that you answered absolutely all of them, and the fact that you're taking on this effort yourself is nuts. So thank you for all of that. But
hey,
basically, now if somebody wants to just experience this, they download the latest version of Aries. They
yep.
download from the archive.org rips and put it on an SSD, and that's basically it, right?
Yeah, pretty much. I would suggest right now, if they're watching it, today, the day this comes out, you probably have to check my website because I haven't got them all on archive.org yet. I've only got 4 up there actually, but there's more tiles coming out, you know, as we speak,
Yeah.
and yeah, but yeah,
I would
um,
assume too, I'm sure people listening are gonna ask if you've spoken to anybody on the Mister team about trying to get this integrated on FPGA, and
I
I'm
have not.
sure
Yeah,
the whole giant file size is gonna be a problem in the short term and might not even run in the D10, might need to wait to the D25 Nano, but have you actually spoken to anybody about that?
I haven't. A lot of people have asked me though about the almost like a tangential thing about can we make an optical drive emulator for the LaserActive and just plug a cartridge into my Mega Drive, and do the emulation for the LaserActive the same way they currently do for Mega CD. It's all technically possible. It will be
Hmm.
challenging, right? And they're not challenges that are insurmountable, but they are challenges that will definitely test, some of these approaches. So if a smart guy has the time and inclination, they can probably make it work. Yeah, I haven't had any in-depth discussions about that with anyone, but people have been asking. I know it's a thing people will want to see one day. We'll have to see what happens.
Yeah, I'm asking from somebody who is smart enough to know I'm not smart enough to understand the full process. So,
Yeah,
I'm not Dunning Kruger my way through this. I guess I sort of am, but at least I'm being honest about it. So it's
yeah,
just, I get how many pieces have to come together. I was just kind of curious. And, if you ever wanted, I'm sure
yeah.
you could get in touch with a lot of people over there, but many of the Mr. Devs are friends of mine. So you could, always reach out if you have any questions on that.
I suspect it will be possible. I do suspect you probably have to use a second FPGA just to deal with the analog video and the mixing side, but the mixing side especially is going to be tricky. But it would be possible. It's just a matter of how much work.
Yeah.
Yeah,
And every time I see an amazing project like this, in fact, anytime I see anything that a ton of work is dumped into it, one of the first things I see in the comments is, "Oh, good job on doing the Mega Drive stuff. What about the NEC version, huh?"
yeah, yeah.
So I'm going to be that troll just because let me cut everybody off and just ask. But you
That's
mentioned
okay.
it first too,
I'm
so
happy to mention it. So I started looking at that last week. I've put it down for a few days because I just had life stuff to deal with. But we got the BIOS booting. Actually, getting the BIOS dumped was the first thing. Let me grab so everyone knows what I'm talking about. Ugh. So this is the PC Engine pack, right? And
Mhm.
there's 3 different versions of this. There's 2 different ones in Japan because they rebranded it for some reason, and there's one in the US. So the Mega Drive version of this is the BIOS, a nice socketed thing I can just pull out and shove in my TL886 and dump. On this one, the BIOS is on the back side on an SMD chip, looks like that. It has no specs online whatsoever. But I dumped my BIOS for the first time about a week ago because I didn't realize no one had done it yet. And after that, I was contacted by someone else who'd done a similar thing. So we have 2 different BIOS dumps. We did not have the BIOS dump for the US region yet, though I'm talked with someone who is actively involved in getting that taken care of now. So first step was getting the BIOSes. Emulating them is actually, famous last words, not too hard because the same chip, this little chip here on the board, that's the chip that I basically wrote the emulation code for. It's the thing that exposes the register block that talks to the rest of the LaserActive, and this basically is the rest of the system as far as the console is concerned. It's the
Okay.
same chip in both packs, and because I've basically emulated that chip, and we've done enough work in the last week to work out how it's mapped and what it means for the NEC hardware, just the same way that the Sega pack is basically a Mega Drive plus Mega CD, the NEC pack is basically, sorry, I don't know the system very well, the NEC system plus the CD version of that system plus this extra chip. So we know how that's mapped in. So I'm going to make an attempt in the next little while to um, to actually basically wire up what I've already done with emulation into the PC Engine support in Aries, which I've heard is not 100%. We'll find out how good it is when I try and use it. But I've heard we may hit problems there with Aries emulation support there in general. We'll find out. I'm just going to see what happens. We have rips of the games. It's the exact same process ripping the games for the LD-ROM 2 stuff, the ANC stuff, as it is for the Mega LD. Same format, same way it's used. So I'm ripping those discs actively. But what I'm basically doing right now is I'm focusing on ripping the last of the tiles I have in my collection and
Mhm.
dealing with, some work stuff right now that's taking a lot of my time. So I'm just focusing on all the tiles ripped, and I'll swing back to this soon. If it goes smoothly, we might see LD-ROM support very quickly, or we might find some significant difference or barrier that makes it go slower. We will see. One disadvantage for me is I don't really know the ANC hardware. I knew the Sega hardware inside out. With this one, I have to rely much more on other people who have the system knowledge to help me if I get stuck. But fortunately, there's been a number of people who've been very forthcoming and they're eager to help. So, hoping as a group effort, we can get that one over the line soon.
Yeah. So, I mean, it sounds like, all kidding aside, the ridiculous amount of work that you've done on just the disk ripping itself and the decoding of that seems like a lot more work than the reverse engineering of the packs themselves, right?
Yeah, I would agree with that. I mean, it's fair to say that reverse engineering is something I've got a lot of experience in and I find quite fun. For me, that part felt the easier part, and the analog video part has been the harder part for sure. But it's not to
So
say
it's
that
not
part
like
was
you're
trivial,
starting this
but
entire thing from scratch all over again,
yeah,
but it's
exactly.
no, it's not trivial. It's still really, really hard. It's just you're not starting a 15-year project again.
No.
It's not going to be even close to that because you've already done the hardest parts of it, really.
Yeah, I would love it if I have nothing left to do on the system by the end of the year. That would be what I'd like to see, where I've ripped everything, emulations are working, and it's fair to say that the emulation that's out there, like it does everything perfectly. Like I haven't found a glitch. There was a few bugs I came across with along the way as I was doing them that I fixed along the way. They're usually little things where I made a mistake in my implementation, not necessarily the hardware notes, but things I hadn't done properly. Um, I know of at least one glitch in one of the games I ripped, where Aries kept on playing where it shouldn't have. And it may be from a feature I know I haven't implemented, or it may be another bug. I'll find it when I get to it. But basically, the next version of Aries that comes out, I'll have that redressed either way, and I'll show have the rest of the Mega LD tiles that I have ripped, and that'll be most of the games that exist. There's a very small number of games on the ASC pack, by comparison. So, and a lot of them that are on there were also on the Sega pack. So, um, I'm optimistic that in the next few months, really laser active emulation will be done.
That's
So
exciting.
yeah,
Awesome. Well, Roger, thank you so much for everything, for your, di- almost 2 decades of work getting into this, for making it all happen, for taking the time to have this chat, for explaining everything, because this was cool. I feel like I'm walking away from this finally understanding all the last little bits and pieces of how the laser active works and how you're even able to emulate it at all.
no worries. It's been great talking to you. Thank you very much for your time, and yeah, I hope people have learned something.
Yeah, cool. Well, I'll obviously put links to everything relevant in the description, and I'm sure I'll be nagging you again at some point in the future to have another chat about who knows when the pack module comes out for emulation for TurboGrafx or whatever. So,
Yep, no worries. Well, there's lots of interesting things we can talk about. One thing I haven't mentioned is that I collected the laser active hardware. I've also collected basically everything Sega's ever made since the dawn of time. Any kind of arcade system, on my shelf behind me, if I was to pivot, I've got like dev kits of various descriptions there that some people might recognize.
oh
So,
yeah,
you
we
know,
have a follow up chat in our future, no doubt.
lots of other things we could talk about if your listeners are interested in that stuff.
Awesome. Well, thank you again, Roger. I'll talk to you soon.
No worries. Thank you.